Hi, I'm Gordon Haff, Technology Evangelist with Red Hat. In this presentation, I'm going to take you through what enterprise blockchain is, or distributed ledger technology if you prefer, some of the reasons that you might be interested in using it, some of the conditions that may mean it really is not the right technology for you, some of the areas in which blockchain is being used, and then finally, what is Red Hat doing with blockchain? Thank you. Let's start by talking about what a blockchain is for our purposes here. We're not talking ICOs, we're not talking Bitcoin or other types of currencies. Rather, we're talking about enterprise blockchain. And what that is a shared permission distributed ledger technology visible to and the transactions validated by members of a business blockchain network using a consensus protocol. Now, that was a whole lot of words there, so let me break that down a little bit. First of all, the distributed ledger is shared by those members of the blockchain network. Those members are permissioned. This is not a public blockchain. You have business entities of some sort who have some sort of trust relationship. Doesn't mean they trust each other 100%, but they have some sort of trust relationship, and they are participating together using a consensus protocol. And again, what consensus protocol means, you probably have heard a lot about that in the context of Bitcoin, where something called proof of work is consensus protocol, and it's very energy intensive because it involves essentially doing cryptographic mining. In the case of permissioned blockchains, other types of consensus mechanisms that do require a certain degree of trust among the participants can be used instead. And basically, it doesn't need to be all the members of the network, but you basically have voting nodes that decide whether a transaction is valid or not. There's no central repository. This is a distributed structure. And there's usually no central authority, although that is not an absolute requirement. You can have central authorities. For example, a company might use a blockchain in conjunction with its suppliers, for example. And in that case, it still is a distributed ledger, but you do essentially have one central authority who is deciding who can participate and deciding what the rules around that blockchain are. And then one additional element, and you see this on the top layer of the diagram there, is that you have these things called smart contracts that can be used to take actions based on predefined events. So, for example, if a transaction completes, if you receive a shipped good, if you send money to someone, actions can be automatically taken with respect to that transaction being completed. So a good is delivered, a payment is taken in response to that good being delivered. Just to very briefly go through what the architecture of a blockchain looks like, I already mentioned the smart contract saying they're up on top, but you have a series of blocks. And that all block is a collection of transactions. And you'll see some other features in those blocks. There's something called a Merkle root. All that means is you have a cryptographic hash of the transactions that are going into the block. And then you have a hash of the previous block header. And the reason that this is interesting is that's what forms your chain of blocks. So if you go back in time and say alter the contents of one of those blocks, then it's obvious because those changes percolate down the chain, and it's obvious that there has been some alteration has happened in those previous blocks, and that has various types of implications, which I'll get to. And really, the interesting part, I think, of the technology isn't necessarily so much the technology itself, but rather the characteristics that the technology create with respect to how blockchains can be used. And essentially, a blockchain lets you build a decentralized business network. And actually, many elements of that network are very familiar to things that we have today. So you have a network of some sort connecting different businesses who are partnering in various respects for purchasing goods, delivering goods, paying for things, and so forth. All of those participants have an identity, and in the case of business networks, those are typically a known identity, although they could be pseudonymous in various ways. Assets of various types flow over those business networks, money being digital currency, fiat currency typically, can be one of those types of assets, but also the digital representation of goods, information about the network participants, and so forth. Transactions, just as in today, they describe some sort of asset exchange. So, loans for cash, cash for goods, that kind of thing. You have some sort of legal frameworks underpinning those transactions. So if I deliver this to you on such and such a schedule, you're going to pay me this amount of money. And then you have a ledger to log the transactions, and that's the actual blockchain that we are talking about here. I'll give you one example to make this maybe a little more concrete, and I'm using Hyperledger as the example here. This is a foundation underneath the Linux Foundation, which contains a number of important blockchain projects. You have the actual distributed ledgers. Hyperledger Fabric, which I'll talk about a little more in a bit, is one of the more popular blockchains, distributed ledgers for enterprise use out there. And other project, which I'll highlight up there, is Hyperledger Indy, and that's primarily focused on distributed identities, and there have been some very interesting projects that have been done with Indy. For example, in British Columbia in Canada, has set up essentially something they call org book, and it's a canonical source of information about companies. Then one of the things that Hyperledger specifically has been doing around blockchains to a lot of focus on making things modular and reusable. So, for example, Hyperledger Ursa is a set of cryptographic libraries that can be used by different distributed ledgers. And particularly in the crypto space, one of the reasons that's nice is cryptography has a couple of important characteristics in the context of blockchain. It's very important, and B, it's very important to get right. So if you have a bunch of different cryptographic implementations out there, there's a lot more opportunity for things to go wrong, as opposed to having one shared library that can be used by a bunch of different projects and can be vetted by a bunch of different projects. And you've got various other shared libraries there as well. Now, this is what I think is going to be the interesting part of this presentation. I just sort of wanted to set things up for you a little bit, but I think where it gets interesting is what can you use distributed ledgers for, and conversely, what might you not want to use them for. So I think the way to think about where you might want to use distributed ledgers is to think about some of the characteristics. And one of those characteristics is distributed trust. No single entity controls the storage and validation of transactions. And if we kind of think about how business is often conducted today, there's a lot of checks and balances that go into establishing different types of trust relationships between entities. And one of the interesting things that blockchain does is it's a way to essentially trust but verify in a way in a business blockchain network. So the sort of the cryptographic setup of the whole thing is one way to not absolutely guarantee. I think there is a mistake that's sometimes made in thinking about blockchain is that, blockchain eliminates the need to have any sort of trust relationships. Blockchain does everything. And even in a permissioned blockchain like this, I would argue that's not completely true. There's still kind of the idea you need the rule of law, you need to enforce contracts at some level, even if they're smart contracts. You need a legal system in the event of disputes, in the case of maybe bugs or mistakes. But it certainly does provide a way for entities with at least some level of trust in each other to cooperate in a lower friction sort of way. A second characteristic, which is interesting and is also interesting because it's something of a double-edged sword, is the idea of immutability. As I went through with the way that the blocks are chained together using cryptography, you can't just yank out a previous block. And if you change it in some way, it's going to be obvious that it has been changed. That actually has implications, though, for how you use blockchain, because that's different from a traditional database where a controlling entity can make changes to records, and sometimes you want to make changes to records. You want to, say, expunge transactions after a certain length of time, say past legal retention requirements or whatnot. And you can't do that in blockchain. And there's actually been some discussion that has gone on around things like GDPR and whether that's a problem for blockchain in some circumstances or not. And one of the sort of architectural implications of this is you have this idea that there is some information that is on the chain and it connects to other information that is off-chain, and that information that is off-chain can be deleted and changed and so forth. So the sort of the thinking is that when you architect your application, there may be some information you actually do keep on the blockchain, and then other information that is essentially not immutable and is incorporated essentially by reference. I think this is maybe one of the big ones with blockchain, and I'll kind of tell you why in a moment, is that you have this idea of parties securely interacting, and there's a single source of truth they can all agree to. And another way to think about it is there was a common message bus for recorded actions that connects entities in a standardized way. And one of the questions early on around blockchain, particularly in an enterprise context, was, well, if these parties kind of trust each other and maybe there's a governmental entity that sort of oversees this all anyway, why can't you just use a database, have parties communicate like they do today? And what it turns out is that in real life, a lot of people are using different systems. There's reconciliation needed, and so forth. So even if there are essentially trustworthy systems that exist today, it actually turns out to be a lot harder to reconcile everything than you might think it needed to be until you dive down into the details. I mean, in the U.S., we often don't get our tax records from our finance companies until maybe the end of February or something like that. And one of the reasons for that is the need to reconcile a lot of disparate systems that weren't originally designed to communicate with each other. But why not blockchain? I've told you all the reasons it's really kind of cool and wonderful and you should use it for everything, but why might you not? And the answer is sometimes conventional databases are just fine. You have a single entity in control, and all their suppliers have processes that they need to follow in order to interact with the mothership's database and records, and that may be a perfectly good way of doing things. And I just talked about immutability. I mean, there are some advantages to having a mutable database that you control, and you don't need to worry about this immutability feature of blockchain. A company wants to have this really centralized control, and I'll talk about this in a little more in a second. And also, performance definitely continues to be an issue with blockchain. It's something a lot of work's being done on, but certainly if you have very high throughput, high data type of transactions, and maybe those other characteristics of blockchain are maybe nice to haves, but they're not necessarily critical, maybe a database is better for those types of high transaction applications. The participating entities are all part of the same trust domain. I guess a good example of this might be within a particular company or within a very closely linked set of organizations in the public sector where pretty much there's a sort of a common level of trust, a common level of access. So you don't really need this sort of distributed trust kind of relationships. And because, again, it's not an absolute rule, but you can think about distributed trust in these business networks. And there is some level of trust for them to have been let into the business network in the first place. But they're, in many cases, competing entities. So they're definitely not in the same trust domain. I mean, they all have secrets. And yeah, we could probably argue that within a given company, you have organizations that have some secrets of their own, but is obviously a very qualitative difference from a bunch of external, separately incorporated parties who are cooperating for business reasons. Assets that can't be reliably digitized, and this I think we can worry about this too much. I mean, for instance, in the supply chain area, which has been one of the early use cases where blockchains had some success, people ask, well, what if you have forged documents, or what if the inspection the customs official said was done wasn't really done because it gets slipped a bribe, and those are absolutely legitimate concerns to bring up. However, I think sometimes we can get into the perfect being the enemy of the good in these kind of discussions. And even if you kind of make it harder to forge shipments that don't actually exist and that kind of thing, even if you eliminate 75% of the fraudulent or unverified transactions, that may still be a win, even if you can't really get there 100%. But this is certainly something to think of, and I think some of the proposed use cases for blockchain, like some of the land title verification and so forth. When the problem is that you have very fragmentary records that are scattered all over the place in dusty county clerk offices and situations like that. Yeah, blockchain would be a good answer if you were maybe starting over from scratch, but it can be very hard to deal with those legacy undigitized systems. This has been a big problem early on. I think some of the early supply chain work in particular struggled with this, that you often have competitors who are participating in these business networks, and they're often not used to this level of transparency and cooperation. They're not willing to give up that control. They're not willing to change their existing practices, and fundamentally they just don't want to cooperate with each other at any level. And under those circumstances, it can be very hard. If only half your suppliers will sign up for the blockchain, it's a lot less useful than if most of them do. So I think in the open source world, where I do a lot of my work, we've kind of gotten used to working together in open source software in this way, where competitors are working together on an open source project. However, I think it's still very hard in many industries for organizations to think about things in that way. And then finally, this probably doesn't need much of an introduction or preamble, but as with many other things, if you're introducing blockchain to solve a problem that really is kind of ugly and legacy and all that kind of stuff, but at the end of the day, we have a working system. It's not a big deal. Maybe just leave it. These are some of the early use cases that we've seen in blockchain. Now, if a few years ago you were at some presentation in this general vein, you'd probably see slides filled with hundreds of small print types of places where blockchain could have an impact. And we certainly see pilot and even production projects in a pretty wide range of areas. But these are the ones that I would say we see most of the activity. Finance is a big one. They're already used to digitized electronic networks. Some of the biggest opportunities in the near term that we've seen in finance are in various types of lending and international transactions in areas where existing middlemen are missing or they're very expensive. So for instance, we've seen a fair bit around international transactions of various types in areas of Asia where there have been fewer low-cost and well-established middlemen of various sorts built up as they tend to have been in the U.S. and Western Europe. Public sector, I mentioned the British Columbia example of a business network, and various types, and this is closely related to that, of identity. The British Columbia example was actually using Hyperledger Indy. And so governments are kind of interested in that in terms of ID cards, business records, that kind of thing. Supply chain and provenance has been talked about a lot and is absolutely having some success, such as a food trust network, for example. There's a lot of concern about if there is an outbreak of bad food of some sort, the desire to really identify that very quickly and not having to be backtracking through records that may be incomplete and that might take months or more. It might take months or more to definitively spot the source of the outbreak, by which time it may very well be too late to do much about it. Healthcare records, this is certainly a great hope, particularly in places where electronic healthcare records have been a bit of a mixed bag. I think this also points out, though, to some of the challenges with blockchain is to a degree that entities can't agree in standards, to a degree that entities don't want to participate in networks. Blockchain can't really solve that political aspect of things. It can really help with the technical aspects, but if entities are not wanting to cooperate in that way and put their heads together and agree on standards and processes, blockchain isn't going to magically waltz in and solve that problem. And I think other types of identity, I mentioned kind of the public sector in particular, but there is a lot of interest in this idea of people having self-sovereign identities and having more control over their identity records than there's a real mechanism to today. And then finally, there is interest in the telco space. And here, again, this has to do with there's a lot of transactions among a lot of different entities and doing the billing and reconciliation for all that. Close and start talking very briefly about what Red Hat is doing here. We're participating in select industry organizations and engaging with customers and partners. One of my colleagues, Mark Wagner, is in both the governing board and the technical steering committee for Hyperledger specifically. We're enabling Red Hat products. There were some security things related to how Hyperledger Fabric specifically was using Kubernetes OpenShift, for example, which Mark and others have addressed, so that you can run on RHEL, you can run on OpenShift, and towards having Hyperledger Fabric on OpenShift, one of the projects that's going on is development of an operator for Hyperledger Fabric. For those of you not familiar with operators, it's something that actually came out of CoreOS originally, which Red Hat acquired for Kubernetes and for OpenShift. And the idea is that with these increasingly complex products, you really want to codify some of the operational knowledge in order to make make code work. And therefore, and the idea with an operator is that you're essentially putting the operational knowledge in order to deploy and do the ongoing management of the software that the operator is for, and have it in a operator hub that you can download and then use. Finally, before going to Q&A, I'd just like to clarify that one of the things that we're not doing is a Red Hat blockchain product. So we're enabling Red Hat platforms to run blockchain products, starting with Hyperledger Fabric, but we do have no plans to sell our own product. We are really agnostic about technology in terms of which particular blockchain platforms we work with, but we've to date had the most customer interest around Hyperledger Fabric. So with that, we have a little time for Q&A.